Okay, yesterday we already discussed how to change the complex number into polar form. What you need to do if change complex number to polar form, you need to find modulus argument. Okay, modulus is find this r. The modulus argument is the angle theta. Okay, so you must find modulus argument, then substitute into the pattern of the polar form, then you get the polar form. Okay, this is the polar form. Z1 and Z2. It's called polar form. Okay, so if I want to multiply the complex number, this one I normally I change it to polar form first. Okay, this is the proof of show that how to get this formula. Actually, we use this formula on it. For multiply, we use this formula on it. Okay, sometimes they might ask you to prove the formula. So you need to use the two polar form for different complex number in general form. Okay, if you times together, you get this. This is R1 cos theta 1 I sin theta 1 times the R2 cos theta 2 plus I sin theta 2. Okay, when you combine these two, the R1 and R2 times together, then this group, these two inside the bracket, then you expand it. When you expand, you get this. Expand, you know how to expand. This the first one times second times the second one, then second one times the first and times the second. So you expand, you get this. When simplify, okay, you group this cos theta 1, theta 2. Then sin theta 1, theta 2, you'll get this. Cos theta 1, cos theta 2 minus sin theta 1, theta 2. Okay, then here is cos theta 1, sin theta 2 plus sin theta 1, cos theta 2. And then from here, you have learned before the formula for the cos and sin. Adding of two angles for cos, you can express as cos A cos B sin A sin B. Then the sin A plus B is sin A cos B plus cos A sin B. So this is the formula for the trigonometric. From the formula trigonometric, okay, this one can simplify into cos theta 1 plus theta 2. Then this one can simplify to sin theta 1 plus theta 2. Okay, so the Z1, Z2 formula is, you can use Z1, Z2 equals to R1 times R2, then cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. And then this R1, R2 actually is the modulus for the first Z1 complex number, and then R2 is for modulus for Z2, right? Then this theta 1 is the angle or the argument for the first complex number, then theta 2 is the second complex number. You can see if you times together, you times the modulus, then you plus the argument. Okay, so this is the formula. If you divide, okay, actual one, I divide like this, I need to expand. Okay, if I divide and the bottom you have complex number, if you want to need to simplify, you have to times the conjugate. Okay, conjugate, you always look at I. In front of I plus, conjugate is a negative, right? You put negative. So after you times this, you get the real number here. Because you times a conjugate at the bottom, the top also you need to times a conjugate. So that is normally if we have this type of question, we do normalize, we times conjugate, simplify, and then expand and simplify, and then get the answer. But when you simplify until this step, you find that this is this trigonometry expression can express in cos A minus B. So this cos theta 1, theta 2 plus sin theta 1, sin theta 2 can be changed to cos theta 1 minus theta 2. Okay, so this one can change to this, and then here this can change to this. Okay, so this is the formula. So we have two formula you need to know. The first one is multiply, second is divide. If divide, you divide the modulus minus the angle. So we have this, these two. Okay, if you want to find the product of two complex numbers, multiply the modulus. Moduli is two, more than one modulus is called moduli. Moduli. Okay, then add their argument, right? Like this lah. Okay, if you times together, modulus equals to times of two modulus, and then argument is you add the argument, just like this. You add the argument, you times the modulus. Okay, and then next, if you divide, want to find the quotient, quotient is divide, two complex number, you divide the modulus, divide it, you divide separately, then argument of z1 over z2, you minus the argument. Argument is theta. z2 cannot be 0, because if 0, you cannot find any answer. Okay, so subtract their argument. Okay, we look at example now. Okay, example 8, find the modulus and argument. Okay, you have to read the question carefully. They ask you to find modulus argument, you must follow the sequence. I see some of students give me, when you do the exercise, you didn't follow the sequence. If they ask this first, you find this first, then find this. Don't find polar form first. Like that. I mean sequence is, ask in the beginning, you find the beginning one first. Okay, don't find the bottom answer first. You must find according to the question sequence, modulus argument. But this one is because together you can find argument, modulus, never mind. Okay, modulus argument. So you try to find modulus for this complex number. Okay, they give you 2, so you must write again. Don't straight away find modulus argument, only didn't state the complex number. Okay, first you state the complex number, then find the modulus, then find the argument. After that, substitute the modulus argument into the polar form. Okay, this is polar form. The pattern of polar form, that one is the subject of the complex number. Then this is Cardassian. Actually, this is Cardassian. Cardassian form, Cardassian is the plan 2D. Got Argand diagram is Cardassian, okay, Cardassian form. Cardassian form is this, Cardassian form. Like y equals to mx plus c, all that are Cardassian. Okay, polar form is polar form means got sine, cos, theta is in angle form. Is polar form. Yes, they got wave, angle, trigonometry. That is polar. But wave, wave polar. Okay, so Cardassian form is in like Argand diagram is a Cardassian form. Okay, so this is Cardassian form. Okay, z equals to 1 plus I is Cardassian form. So change to this is a polar form. Okay, polar form involves cos and sine. Okay, every time remember the angle for polar form must between what to what? Polar form angle must be negative pi until positive pi. Remember all this polar form. Okay, so the angle here, after you find the argument, okay, you check first. Okay, if you want to find the modulus argument, then polar form, first, okay, find modulus, then you find argument. Okay, to find the argument, what you need to take note, yesterday I said already, okay, you have to check where is the position of this, correct or not, in the Argand diagram. This is positive, so in first position. So if in the first quadrant, normally no problem, you straight away press, you can get the answer already. Okay, so this pi over 4 is from the one, you press arctangent 1, you get 45 degree, right? You press calculator, arctangent 1, you get tangent 1, you get 45 degree. Yes, correct or not? Okay, and then argument you must change to pi or change to radian. You must write in radian, you cannot write in degree. Okay, so you just change 45 equals to 45 over 180 pi. Then you get 1 over 4. That's why 1 pi over 4. Argument z is pi over 4. Okay, so because first quadrant, no problem. Okay, then you substitute into polar form. Okay, so you settle one modulus argument, then polar form. Okay, you have modulus argument polar form. Settle. Okay, so for the first one, second one also like that. Modulus, first you find the modulus, then for argument you check. Because you have real part and this is imaginary part. Okay, so when you draw in the Argand diagrams, where suppose you have to draw in the Argand diagram. Sub 3 is positive. This is negative. So should be at the bottom right. Okay, here, right? Here, correct or not? The Argand diagram, if you draw this complex number, should be here, right? Okay, because sub 3 positive. Maybe here is sub 3, then negative 1 at the bottom. Okay, so here, okay, at the fourth quadrant. If at the fourth quadrant means you need to get a negative angle. Okay, every time negative angle, you know, just in your mind, this is a negative angle I need to find. But when you press calculator, you press this. Okay, you press this. Press this, you get, okay, you get 30 degrees. So, okay, if 30 degree means 30 over 180 pi, you get 1 over 6 pi. That's why pi over 6. So you get pi over 6. But because of bottom here, oh, here missing. Okay, put negative pi over 6. Okay, so that's how you get the argument. Okay, make sure every time when you want to find the modulus argument, modulus normally no problem, always positive. But the argument you have to be careful. If both positive, no problem, you straight away press, you can get the first quadrant. But if negative, you have to be careful. You have to be careful. Where is it? Is it here or here? Okay, if both negative will be here, but you see a positive. Because both negative, the y also negative, x also negative, as well as you will get positive. But because of both negative, you need to know where is the place of the complex number first. Only you can decide what argument I need to put. Okay, okay, you must remember this. If not, you will get all wrong. Okay, if you very lucky, you get the first quadrant, normally no problem. Everybody will get correct. But if got negative, okay, that time you have to be careful. Is it here or here or here? Okay, these three places. Okay, make sure here is maximum pi only, minimum negative pi for argument. Okay, next. After you get the modulus argument, you put inside the polar form. So settle. Modulus argument and polar form. Okay? So you have these two. Okay, after that, now hence they said after you get these two, you must use this to find the z1, z1, z2, and z1, z2. z1 over z2 and z1 times z2. Because they mention hence. So you need to use the answer from here to find z1, z2. So z1, z2, okay, you just look at this. This is z2, this is 2. So I combine this together, 2 times 2. And then this group, the whole group you copy down. This group you copy down. Okay, whole group. Can you see or not? This is the first group, copy down here. The second group you copy down here. Or you can say, oh, actually I copy this one. Cat. Write one more step. 2 cos pi over 4 plus I sine pi over 4. Okay, the whole thing times together with, okay, this is z1, z2. Okay, so that not confused. Okay, you copy exactly the same thing. This group copy down and then this group copy down. Why you need to do that? Because dimension hence. So you need to use the answer from here. Everything from here copy down. Everything from here copy down. Then you will get correct. Okay. Next is the operation. Okay. First step you need to show the substitution. Okay. Second you need to use the formula. Okay. This one. Okay. Use the formula. So you know if you multiply two complex number for polar form, you multiply the modulus. These two and sub2 you multiply. And then here, this one second step. 2 and sub2 multiply. And then your angle here, pi over 4 plus negative pi over 6. So pi over 4 plus negative pi over 6. So pi over 4 minus pi over 6. You write this. Number 2 also the same. Angle is the same. This and this is same. Yeah? No plus minus. Okay, so if minus, both also minus, same. Okay, angle will be set. Okay, then simplify it. Okay, you get the answer. And then you have to check whether this is between the pi over 12. Is it between negative pi until pi? If bigger than that, you have to check where is the position. Then you try to check the angle. Okay, simplify the angle. But now is if less than pi, less than means you can look at this actually very easy. The fraction here. If the fraction less than 1, then step already. If more than 1, then you have to simplify. Okay. Yeah, this one 1 over 12, right? 1 over 12 less than 1, right? And then step already. Okay, no need to simplify. Okay, this one also the step. Divide, you copy the whole thing. Polar form for the first group. And then polar form from second group. Copy. Put there. You will get the marks. Then after that, do the operation based on the formula. If divide, I divide the modulus. I minus or I subtract the angle. The argument. Okay, I subtract. Pi over 4 minus negative pi over 6. So I become pass. Okay, so I get this. So you write this and then get the answer. 5 over 12 pi. 5 over 12 pi. Okay, then settle. Okay, you check the angle. Less than pi. Less than pi. Then set. If more than pi, you need to simplify. Okay, next. Example 9. Given two complex number. Okay, now a bit different. Look like same, but you look at the question, they ask differently. They give you complex number, find modulus and argument. Okay, they didn't ask you to find the polar form. Correct or not? You see what is the difference with this? This one they ask you polar form. This one they didn't ask you polar form. Okay, so you just need to, because they asked about modulus argument only, just need to find the modulus argument. And then here also modulus argument. Make sure you state the complex number. Okay, modulus normally no problem, all positive all the while. Okay, for argument, be careful. This is negative, positive. So in the second quadrant. Okay, second quadrant, you try to check. Arctangent 1 is 45, right? You find arctangent 1 is 45. Okay, if 45 means 45 over 180, so you get pi over 4. Because of second quadrant here should be, okay, here, if second quadrant means here is pi over 4, so pi minus pi over 4, so you get 3 pi over 4. That's why here you put 3 pi over 4. Understand? Why 3 pi over 4? Because second quadrant. Because of second quadrant, you use pi minus this is the reference angle, basic angle. Here. Okay, next. This is 3 and positive, both positive, normally no problem. You just write there, okay, positive, press the up tangent, then you straight away can get the answer already. You get how many divide by 180, put a pi there. Okay? And next, after that, they didn't ask you to form the polar form. Then they ask you hence. Hence means you have to use this to find the answer, but don't have polar form here. Okay, in your knowledge is you know Z1, Z2. No need to have polar form also, never mind. You just based on the modulus and argument, you can find the answer. Okay, if Z1, Z2 modulus, you just times the modulus, you get modulus for Z1, Z2. Then argument, you times together, you add the argument. Show the plus. Okay, show the adding of two arguments. Then what is the answer after you add? Okay, then you put inside the this okay, and then you check. I think this one should be changed. This 13 over 12 is how many? 13 over 12 times 180. How many degree? 195. Okay, so 195 degree is in here, right? Correct or not? In a third quadrant, right? I think you should change. This is not correct. Okay, you have to express in polar form. This one is 195. Okay, so how to change this? If 195 degree should be how many? Here to here is how many? 165. Okay, 165 over 180 pi is how many? So equals to 11 over 12 pi. So this one should change to cos negative, because negative angle. Negative 11 over 12 pi plus I sine negative 11 over 12 pi. So make sure if this angle is more than 180 or more than pi, you must simplify it. Okay, in some books you may write like this. Cos, well, negative cos is positive 11 over 12 pi minus I sine 11 over 12 pi. Okay, now I want you to press this. Okay, you check. If you press cos 13, means you press the, 30 over 12 pi is 195, right? Okay, try to press the cos 195. What is the answer? 9659. 9659. Okay, this is cos 195. Okay, if you give me this what? Negative 11 165. Okay, this is 165, right? So you try to press cos negative 165. Can you get the same thing? Can you get negative 0.9659? Correct or not? That's why this angle is equivalent to this equal. The negative angle. This is negative angle. Negative 165. This is positive 195. Okay, correct. Okay, the answer will be same. Okay, so if they ask you to write in polar form, actually you can write in this form, or you write in this form. Normally, write in this form enough already, because you simplify into the simplest angle. Okay, why simplify into simplest angle? Always remember, for polar form, the angle must be between negative pi to pi. You just set in your mind, polar form angle must be negative pi to pi only. If more than that, I have to simplify. Okay, how to simplify? Whether negative or positive, you check the place. If the place in first and second quadrant normally is positive. If in the third and fourth quadrant is negative angle. Okay, okay or not? Okay, you remember this. Then always will be correct. Huh? Okay, it's polar form. But if they want you to write in Cardassian form, later we have Cardassian form in here. Cardassian form, actually you press this, you straight away press this, you get this answer in numbers already. This is Cardassian form. Cardassian form means numbers form. The complex number in numbers form. No, you don't see any cos and sine anymore. Cos and sine is a polar form. Okay, if Cardassian form, you no need to do all this. You straight away press this, you will get this answer already. The other one, you get another numbers the numbers in decimal place. You can press sine 195 is what? Okay, with I. They have another number here, but that one later, discuss later. Okay, for divide also like that, divide. So normally we use the modulus and argument only. Modulus for R, okay, then argument I minus. Okay, then after you get the answer, you substitute into the polar form. Then you get the answer already. Normally minus, you check if this is less than, is in between negative pi and pi, then set correct. No need to check. If outside, you need to change and then you need to check where is the position. Okay, so you need to remember this only every time. Okay, next is the De Morey theorem. What is the time now? Okay, De Morey theorem is further from here. Okay, so if we know already, if I have Z1, Z2 in polar form, if I times together, I will have this formula. If Z1 equals to Z2, if both are same, so I let Z1 equal to Z2 equal to Z. So if same means I times together, I will get Z squared. If Z squared, the R will become R squared. The theta 1 and theta 2, if there is theta, both also theta plus theta, I get 2 theta. This one also theta plus theta, I get 2 theta. So I have another formula now. This is called De Morey theorem. Okay, you look at what is De Morey theorem. If I have another complex number, also the same R, okay, I times another Z. This is Z square, right? Z square. I times Z. So for R also, I times the R square. I times another complex number. Wait, like this. Means this is Z square, right? Actually, this. Okay, I want to find Z cube. Is Z square times the Z, correct? So the Z square actually is R squared cos 2 theta plus I sine 2 theta. Okay, the Z is times the R cos theta plus I sine theta. Okay, means Z squared times Z. This is Z squared times the Z. So will become R cubed. Cos 2 theta plus cos theta is cos 3 theta plus I sine 3 theta. Can you see or not? I get this. If raised to the power of 3, the R will become R to the power of 3, and then theta will be 3 theta and 3 theta. Can you see? Can you see why like that? Okay, if raised to the power of 2, R squared, angle 2 theta, 2 theta. If raised to the power of 3, R cubed, angle 3 theta, 3 theta. Can you see or not? If raised to the power n, R to the power n cos n theta, n theta. Okay, this is called De Morey theorem. So now we will find it very easy. If I want to find the complex number raised to a power of integer. Okay, we just change to polar form. Then based on polar form, I can easily find the complex number raised to a power of integer. Okay, so this is the formula. Okay, so like this. Okay, power and roots of complex number. So for power, we have this step. Later we look at it again. Okay, we look at the example first. Okay, use the De Morey theorem to find the complex number raised to the power of 10. Okay, normally if I want to raise to a power of 10 for any expression, normally we expand one by one, right? Times this is one number times one number times one number times 10 times, correct or not? We need to expand one by one, very difficult, correct or not? The step will be very long. But now, if you know De Morey theorem, this is only for complex number, for others cannot. Okay, only for complex number you can use De Morey theorem. Okay, Z. Okay, let the Z become Z3 over 2 plus I 1 over 2I. Then you find modulus argument, then write in polar form. This is the general step you must take first before you raise to the power 10. If you want to use De Morey theorem, okay or not? First step they won't ask you about change to the polar form. No, in this case they won't ask you to find modulus argument change to polar form, but you must know. If they mention De Morey theorem, you must change to polar form. To change to polar form, you must do modulus argument. Okay, make sure argument must be, the angle must be between negative pi to pi every time. Okay, so you check this is smaller than pi, greater than negative pi. Okay already. You just put inside here. Here is 1. Actually, 1 should be put at the outside here. But now because 1, no need to put also, never mind. Like this 1 times it. Okay. So actually this you have to write like this. If you didn't state Z equals to, let the Z equals to this, you must state the whole thing. The group of complex number raised to the power 10 equals to the group of, this is what you have find before this, modulus, argument, and polar form. This is the polar form. Okay, you have 1. Actually here should be have 1 because your modulus is 1. Okay, you have 1 modulus, argument is pi over 6. Okay, this is in polar form. Okay, write exactly like what you find here. The polar form put inside here becomes raised to power 10. Okay. Okay, first step. Okay, actually this step you do first, then substitute into actual one. What you want to find? You want to find this complex number raised to power 10. So after you change to the polar form raised to a power 10. Then because raised to a power 10 follow the De Morey theorem, the modulus raised to a power 10, same because this one times raised to a power 10. Inside there, the argument times 10. Easy, right? You times 10, then simplify it like this. Times 10, you simplify, you get 5 over 3. You simplify it, you get 5 over 3, 4 over 3. So you get this after here, you get this. Okay. So 5 over 3, you check 5 over 3 is more than pi, right? Okay, what is 5 pi over 3? Get how many degree? 5 pi over 3 is how many degree? 300, right? You check. 5 pi over 3 is 300. Just now I get. Can you get 300? Okay, 300 means in the fourth quadrant. Okay, in fourth quadrant, the other part, negative is negative 60. So you find for 60 degree. Okay, for 60 degree, it's pi over 3. 60 degree equals to pi over 3. Okay, so because negative, you put negative pi over 3. So this 5 pi over 3, you change it to negative pi over 3. Can I understand why negative pi over 3? Because this one more than pi already. Okay, if more than pi, you have to check where suppose you have to put. Okay, you find that there is in fourth quadrant. So fourth quadrant is negative angle, so you have to count from here to here is 60. So 60 is pi over 3 because negative angle, you put there negative pi over 3. This is negative 60. So you change the angle to negative pi over 3. Negative pi over 3. Okay, then take out if you didn't take out also never mind. But here, because they didn't mention polar form, if they give you in Cardassian form, you must change it back to Cartesian form. Don't left answer as a polar form. If left answer as polar form haven't finished, you have to do until Cartesian form. This is called Cartesian form. Okay, you change to this. So you change it you can change to this, or you straight away press calculator. I think you can get 1 over 2 already. Can you press this? Einstein? Actually, if they didn't ask you to simplify, you can straight away from here. You press calculator, you will get this. Can you get this? You press this. You try to press cos 300 and then sine 300. Can you get 1 over 2 and sub 3 over 2? Can okay, you get this one negative sub 3 over 2, right? So actually, if they didn't say anything about polar form, from here, you can straight away come to this step, get the answer. But if they mention change to polar form, you must change to polar form and then stop at polar form. You have to base on question. That's why you have to read questions so many times. Whether they want you to write the answer in polar form or Cartesian form. If they didn't mention anything, you follow the question. Okay, three things you need to know. Question. They ask you polar form or not? They ask you Cartesian form or not? If they ask, you follow. If didn't ask, you follow what they give. If they give you Cartesian form, answer in Cartesian form. Okay, answer, follow Cartesian form. Because when you expand, actually this one you expand, at last you will get this. You won't get polar form. You just use the polar form to help you to get the answer easily. Okay, so you must change it back to Cartesian form. Okay, so make sure you remember this. Okay, change to Cartesian form. Okay, so this is what you have to do. Then next, we look at so use De Morey theorem to express each of the following complex number in the form. Okay, you see or not? They ask you to express in this form. So make sure you must write in this is called polar form. So no need to change to Cartesian form because you copy this equals to raised to the power 8. So you just times the 8 years in front, nothing, right? Yeah, you just times cos 8 pi over 3 plus I sine 8 pi over 3. Okay, this is polar form, right? Okay, you can draw a sketch like this. 2 pi and here, this is 2 pi over 3, right? So you can write here equals to cos 2 pi over 3 plus I sine 2 pi over 3. Or you can separate this to 2 pi. Then you simplify because there is second round already. Okay, you can put it equals to this. Then you write cos 2 pi over 3 I sine 2 pi over 3. Okay, so understand or not? As long as there's more than the pi, you have to check. Okay, to the power of 5. Okay, if in this case, what you need to do? Because here negative means that the angle is, if here negative, the angle should be negative. You change to, before you do the De Morey theorem, plus I sine, must plus I every time. Pi over 6 to the power of 5. Okay, you change to negative. If here got negative, both you change to negative. Then negative 5 pi over 6. Okay, what is the angle for 5 pi over 6? 150. But this is negative, right? Okay, negative 150 is here. Okay, then no problem. It's inside the negative, not pi yet, right? Not until negative pi. So this is the answer. No need to change. Okay, so you can write like this in polar form. Because they say cos n theta plus I sin n theta, right? You just write the answer like this. Because you look at the question again. Do I need to take the negative outside here? No need, because the question mentioned you must write it cos n theta plus I sin n theta. Okay, then number 2. Express the following complex number in the form of cos theta plus I sin theta. You need to, okay, you check here. The same number very easy. If here 7, how? Because 7, you change it to cos theta plus I sin theta to the power of 7. Okay, very easy. If negative, you change it to positive. Plus I sin raised to a power of 5. Cos theta over 3 plus I sin theta over 3 to the power of negative 5. To a power of negative 5. Okay. Okay, this power must be integer. Must be integer. Okay, don't take the 3. Okay, this is how you do. You do the BD. AC I've done already. BD. But you do all, you can write all. I give you 2 answers already. Yeah, the other you do. Then number 3. If that represent, okay, you have to write the answer in polar form. So you must find the modulus argument. Then you try use the same method as like this. Okay, find modulus argument, write in polar form, then raise to power. Okay, then simplify and write in Cartesian form. Okay, number 3 you must write in express in polar form, then find the Z5 don't write in polar form. This one write in form, so you change this. Number 3 you write in Cartesian form. Okay, number 4 you write in polar form. The valid already. Use the Pauli theorem, simplify each of the following expression. Okay, this one you write in polar form. Then number 5. Number 3. 4.4 number 3. Okay, the first part is polar form. Then they ask you to express in polar form. Second step, give your answer in Cartesian form. That is for z to a power of 5. Okay, so the first part, number 4.4 number 3, right? The first part you express in polar form. The one haven't raised to power. Okay, then second part you raise to power, you write. Actually, you change to polar form first, then you change to Cartesian form. Means you have to write until Cartesian form lah. Okay, first, maybe you try to change to polar form, then change to Cartesian form. This one, write answer in polar form, then Cartesian form, then write in Cartesian form lah. Okay, so you like this, continue. Okay, after polar form, continue until the last step, Cartesian form. Okay, then next, number 4, you have to write in polar form. This one you get times, you add, divide, you minus, right? Make sure if you see in front of I side got negative, the angle is negative, you change to negative first. Only you plus or minus. Okay? Then number 5 is write in polar form. Then find same lah. Okay, this one you change. The second part you have to write in Cartesian form lah. Polar form already, this one raised to the power of 10, you just follow like example. De Morey theorem, they got two parts. Is raised to a power. You have B part is roots. Part B, this is part A. That's why until number 5 only your question you do until number 5 for part A. The part B is roots. Roots you have second part. Later we continue next week lah. Okay, because I don't want you to confuse later. Because the part B a bit complicated. The roots, you have a lot of answer. So you try to follow this first, complex number for powers first. Calculate modulus, write in polar form, raise to power in polar form, adjust the polar form to theta between negative pi and pi, then change to Cartesian form. You follow all these steps to get the answer. For raised to power, this power must be integer. Okay, numbers. Okay, others than that, there is roots. You will do this later next week. Another part, last part. Raised to power of roots. Cube roots, two roots. The roots, you have a lot of answer. This one got one answer only. If raised to power, you have one answer only. Means this answer, you have one only. Raised to power. One, polar form or in Cartesian form, one answer only. If you have roots, you have a lot of answer. Based on how many roots? Square root, you have 2 answers. Cube root, you have 3 answers. Fourth root, you have 4 answers. Root 1/5, you have 5 answers. Yeah? That's why a bit complicated. We do next week. Okay, this one you try to do. Okay, only you can see the difference. Next week you stay at home, right? If you didn't do, then next week maybe you're a bit confused. Okay, you try to do some of the question, 5 questions only. Then next week you'll see the difference. If you have roots, you have different answer. If you have to raise to a power of integer, you have only one answer. Okay? Okay, so that's all for this. Number 3 also do this. Number 3 do what? This. D, F. If you can, you do all. Does you need normally do all, right? Is it do all? Good.